Hey guys, so I've got this set up here, kind of like well, it is the splitting the positives they call it, but you can do it either way. You can connect your negatives together like that, or you can have the positives hooked together and just hook to the negatives, like I had in previous couple videos. I'll link them in the description. It was with the pulse motor, and there's a certain way you can kind of fool the system to kind of like pretending that you're making extra energy. And I'll explain that as I'll do this quick demo here, but then I'll explain that. So what I got going on here is kind of like the Tesla circuit, right? You got your 24 volt battery and a lower voltage battery here, and you're just running in this case, the inverter. You can run whatever loads you want, DC loads at that voltage right there. That's the difference in between these two. These meters are reset. 13.2 and everything's 0. That was 26.2. In this case here, this battery is exactly half the capacity as that one is. Like in current wise, amp hours wise. The watt hours is what matters though. Like if you're trying to get the same amount of energy, you'd have to have the same amount of capacity with the like if I had two of these here, like I usually do, that'd be the same capacity as what that is. That's a 50 amp hour battery. This one's 25. But I'm gonna turn this on, make the demo here. I got a 12 watt LED here and a couple other ones. Not sure how charged this battery is. It's been sitting like this unused for quite a while. I'd recharge it, but the BMS's use power, so they eventually kill the batteries. Turn it on. Yeah, it looks pretty dead. It shouldn't sag like that. So you can see it's pulling 16 watts out of it just by turning the inverter on. It's returning 8 of it back here. The currents are exactly the same almost. These meters are really accurate. There's the voltage of the battery, like in the inverter, the potential difference. So I'll plug in the light now. And the battery's pretty dead. There's the difference there. It's 21 watts here going in, and 41 right here. Same current. So where you can actually get a little bit of gains with this is when you're getting to where this is really low, that's where you're going to be getting gains, because your voltage right here is going to be low. So let's just say you can see where we're at right now, right? So we're getting about 1 watt extra over here. But that's just because the inverter is only pulling less because the it's dropping, right? So you're getting that imbalance there. So, like, if this was a motor, your motor would be running slower. Like, there's the power is right here, 41 watts, about. It just gets divided up between these two loads. So what you're doing is your inverter is running less efficient. Like, that's just how these, not less efficient, but it's putting out less output power. This voltage will sag when this one goes down. So that's what happens with this system like this. But there's a way you can kind of fool it. Like, it's alright though, like if you're running a load, you will get a little bit of a gain here. Like, you can see it's 21.1. The currents are the same, really close to being the same. 158, 1.58, and that one's getting down to 1.58 too. So this would be equal if the voltages were exactly half. Like, if this was exactly half of that, you'd have equal here. Like, this would be exactly half of what that is. But there's a little bit more right here because this voltage is lower. So it looks like your battery's going to be able to charge up, but you're getting exactly, well, not exactly half. You're going to be, depending on your voltages and what you're pulling for power, you're only going to be a certain percentage difference here of what that is. It all depends on the state of charge of your batteries. So, you get a 40.5 watts here, and we got 21 here. So you're getting half a watt more, like, over the halfway mark, you know what I mean? It's always going to be around half, give or take a few watts, or a percentage, or whatever you're going by. You're never going to be able to charge this battery up unless it's half the capacity of that one. And you'll never ever do it with a lead acid battery. Lead acid batteries, I don't care if they're sealed, AGM, like flooded, it doesn't matter. Flooded ones, like a lead calcium based battery, you have to bring it up to 14.2 volts and float, like, use the absorption charge until it stops pulling current. That's the only way it's charged fully. If you just bring it up to like 13.3, 13.6, that battery's not even close to being charged. They have to have their absorption charge completed, and that absorption charge takes anywhere from 50 to 90% of the whole time it takes to charge a lead acid battery. They're very inefficient. These batteries here, you'll get almost 100% out of them efficiency. So yeah, you would be able to get this battery charged up by doing this, but you're not gaining anything. You're gonna lose right here. Like, you're getting maybe a half a watt extra here in this battery, but that's only because this one's losing energy. Like, the voltage is going down, so the light's not going to be as bright. If you're running a motor, the motor's going to be slower. But there's a way to fool this, like, and I've done the videos with this a couple of years ago, I think 2 or 3 years ago, at a pulse motor that was hooked to it was the opposite. I was pulling I think the negatives were, the positives I think were connected together, and I was running off the negatives. And in that way, with a meter system like this, you can fool it. Like, say if I was plugged in a transformer right here and took the outputs from a bridge rectifier, like rectify it to DC with a bridge, you put your negative right here and your positive right here. So now you're feeding your output from that transformer right back into this inverter, right? Like it's trying to charge the battery up, is what it's trying to do right here. But it's like, say we're pulling 20 watts right here, and that transformer is producing 5. Then you can say that this is only drawing 15, right? So you'll be able to fool your meter. The current will be less here than what it is over here. And do that with a motor, same thing with an output coil. That's what I did in that video. It's pretty much useless, like, unless because you're never going to get your batteries. If you're trying to charge an equal amount of watt hours between these two batteries, you're never going to get this one fully charged, especially if it's lead acid. And if you're running with these, you'll have half the energy in this battery as what you had in that one. That's just how it is. You can see right here. These meters are telling you what's going on. And I've verified it with doing capacity tests. I've spent probably a whole year doing this stuff with this circuit, with pulse motors and different variations of this stuff, different loads. It's a battery killer, especially with lead acid. If you're bouncing batteries back and forth, you will kill your batteries. These ones aren't so bad, but you are putting a life cycle, like a cycle on them every time you bounce them back and forth. So I just figured I'd like to post that anyways, and like, try it too. Like, do the capacity test though. Just don't go by the voltages on a lead acid battery, because it's not true. Like, try to get some proper meters and actually do the tests. You'll see. But thanks for watching, guys. Appreciate it.